Okay, so since I have a sub, you should get these off so I'm not jingling this whole time. I'm just recording this in my off period where there's not even students present, so I'm probably going to go a lot faster than I normally do. Just pause it, and if you need to, you can rewind and fill things out as you need to. I'm hoping that it is animated. I had a brain fart there, but yesterday we did the textures of these igneous rocks, and yeah, a lot of the words, and I even have to double check myself and go back and reread it because this is Latin, and we have a few more that we're going to talk about today. But yesterday was more. You had your intrusive and your extrusive. They came from inside the earth, and they had a specific type of grain size versus extrusive and had a different size of a grain. And we're going to talk more about the compositions of them today. Tomorrow we'll be going back over magma and really how that does affect the type of igneous rock that's formed. I have not built the Kahoot yet, but I'm hoping to build a Kahoot for the review for Thursday. Gosh, worst comes to worst, I have the paper version and we can talk about it, but I'll try my best to create a Kahoot because it seems like that more of you are interested in that than just going over a paper review. And that way I can also record it and put it on my Canvas through YouTube. But our opener says granite is less dense than basalt, which is a true statement, which would be the primary component of continental crust versus the oceanic lithosphere, the crust, the plates. And granite is, since it's less dense and the continents are on the top, granite is going to be a component of continental crust. Granite's actually used to build mountains. Most common rock that you're going to find, igneous rock that you're going to find in mountains. And then basalt is much more dense and therefore was going to be part of your ocean floor or your oceanic lithosphere, your oceanic plates, which then goes down underneath the continents and then subjects and subverts down into the asthenosphere and remelts and then starts this cycle all over again. There is an assignment that goes along with this, typical 10-question assignment. I need to go back and make sure I didn't make any typos as far as spelling things, because like I said, this is more of a Latin lesson at this point with some of these words. But for the composition, we're still doing igneous. Most of your igneous rocks are primarily composed of silicates, which is silica and silicon and oxygen, normally one silicon and two oxygens, but you guys don't need to memorize the chemistry behind this. Now, you have two major types of silicates. Your dark ones are ferrous. Well, ferromagnesian means that they're primarily iron and magnesium. Very, very, very high iron content, and they tend to be more dense. And so examples of this would be olivine, trioxine, the biotype. There's two different types of mica. The darker mica is the biotype. The lighter mica, which I do have somewhere in the cleavage box, which I can't remember if I took that home with me or if it's here in the room. But if I'm not mistaken, both types of mica are in that particular set as well. I'm going to have to double check and look at it. But your non-ferrous, non-iron, non-magnesium silicates have little to no iron content. They are a much lighter chemical composition, therefore they are less dense. And those tend to make up your upper layers of your crust, more of your continental type plates. So quartz, the other type of mica, muscovite, it's a much lighter color. And then also all of your feldspars, which I have a lot of these in the various boxes. I'm just in the process of trying to put together a comprehensive set. So if we're ever allowed to touch stuff, you guys can actually take a look at them. Like I said, if I go too fast, just by all means, pause it, go back. I don't have you guys to tell me, wait, don't go. Granitic versus basaltic. If it's a granite, it's granitic. These are your lighter colored silicates. Like I said, granite is going to be most common that we're going to find in our mountains. They are called felsic, part feldspar, part silica. These are different things that are found in the upper layer of the crust. But they did like a, what do they call it when they take two celebrities' names and smush them together? I think there's a phrase for it, but they literally did that. They smashed the two together. And they do have very high amounts of silica. And this is the chemical formula for silica, mostly used to help make up the continental lithosphere, or the crust, or the plate. All of those words are interchangeable with each other. Oh no, I didn't. I'm gonna print this out. My cheat sheets all like, it printed weird. Okay, that's strange. Okay, I'm not on that page. I'm not on that page yet. I'm ahead of myself. Okay, basaltic, the other major component, it's much darker, is going to have a lot more iron. That's what the ferromagnesian, ferrum for iron, and the magnesium from the magnesian part. They literally smushed them together too. So it's called mafic. Much, much, much denser. They're going to find more calcium present in these, especially deeper down when you're getting towards olivine. And these are going to make up your ocean crust, your oceanic lithosphere, your oceanic plates. And they also can make up your volcanic islands. So when you have your magma that's pushing up and it creates lift, and then eventually, and it's spewing out as it's doing this. Well, that's basalt that comes out on the top, and it just keeps growing layer after layer up out of the ocean. And then, just like the Hawaiian Islands, a lot of your island chains have very, very dark, fine sand and dirt particles, and that is the broken up basalt. The basalt is the most common of the extrusive igneous materials. In fact, if it's inside the earth, it's not necessarily called basalt. What's outside the earth is called basalt. Inside the earth, we normally call it gabbro. We'll get to some of these as we go on. I don't want to get ahead of myself. Hopefully I can get through all of this before the bell rings for my chemistry class. I don't know what I'm going to do if I run out of time. I guess I'll just record it twice. Okay, intermediate, which we call andesitic. So it's a smush of the things that we had before. You are going to see this stuff with volcanoes. Okay, so you've got the inside of the earth that's very rapidly becoming the outside of the earth. And it's extremely high in iron. This is what the ultra mafic, extra mafic composition. Very, very rare, but it's high in that mafic, which is magnesium, and then ferrum. And that's what mafic comes from. They smushed them together. And there you've got the same thing, magnesium and iron, ferro, magnesium silicates. Very, very, very dense material. And like I mentioned yesterday, with your granite, the darker the granite, the denser the material, and it's actually easier to take care of darker granite than it is lighter granite. A lot of people like the nice, pretty light granite, especially since it has all different colors in it, but it's much more prone to staining. If you've got oil from cooking, or you got a little kid that is not paying attention when they're painting on your brand new granite island, like mine did last weekend, at least it came off. You just have to be careful if you do have lighter granite. Next one. So the amount of silica that is present, and it has a big range from 40 to 70% in the crust, is going to help determine what the rocks appear, their densities. I said the silicates are a lot less dense than your iron, your mafic, your felsic are a lot more lighter. They are less dense than the corresponding mafic. The amount of content is going to control how the magma actually behaves, how it moves. We're going to talk more about magma specifically tomorrow, but the amount that's present, it changes what we call the viscosity, how slowly the magma actually moves. Your granitic magma have more silica content and they're thicker. Okay, they move slower. Viscosity is the resistance to flow, if you've ever heard that word in chemistry or maybe IPC. And then your basaltic magma have lower silica content and they are more liquid-like. Obviously, it's magma, it's not water, but they move easier. They are less viscous. Granitic magmas are more viscous. They move a lot slower. And once again, if I go too fast, by all means, just pause me. I'm about to click on my button again and have you guys to face me. We have lots of pictures naming these different igneous rocks. Granitic rocks are granite. And like we mentioned yesterday, there's all different kinds and colors of granite. The granite that I have in my kitchen even has purple in it. My daughter, her favorite color is purple, so she was so excited that we had purple in our kitchen out of stone. It is phaneritic. Okay, it is intrusive. So we have large coarse grains because of the way that it cools. It's inside the planet, therefore slower cooling, larger crystals. It's primarily made up of feldspar and quartz. It is the most common rock that you're going to find in mountains, inside the mountain itself, not on the surface. That's weathering, that's sediment. But your phrase granite, there are so many different types. And I have the one that I have up here in my box, it's right next to me, has red and pink in it. I'm not sure specifically what the name of this type of granite is, but they have different names for different colors and different patterns. Okay, the next type we're going to talk about is rhyolite. And I have two different types of rhyolite actually in this box. This is a lighter color. It is the extrusive version of granite. So this is the granite that has actually come up onto the earth. It can have glass in it. Things like when we say glassy, you think of obsidian and you think of pumice. So it can have that shiny glass type structures. It can have holes in it. This is aphanitic in texture. Aphanitic because it is extrusive and therefore it is a lot finer grain. But granite's definitely the more common of these two. So, and we're going to have a lot and this is this guy's cousin today. So with granite, that's the interior of the earth version. The rhyolite is the exterior of the earth version. But they have very similar chemical compositions. The difference in the grain is because the fact that the rhyolite has cooled much faster and the granite has cooled much slower. That's what causes the difference, the large difference in the grains. Okay, more granitic rocks. Obsidian, this is the one that you guys got to hold last week. So it's what you think of as glassy. But the pumice is also glassy. It's just been frothed by the fact that it was thrown into the air, and then the air made these little air pockets that we call vesicles or voids. There's holes in the rock, but it's still glass. It's just not what you think of as glass. You think of the pitchstone and the obsidian, the smooth, glassy surfaces. It just has to do with the atomic structure on if it does appear to be nice and smooth, like the obsidian that we can turn into knives and arrowheads and spear points, versus the pumice that people literally use to scrape the dead skin off of their feet. But they're still both glassy. Okay, intermediate rocks. Let's see where I am on my cheat sheet. Andesite, which is the one on the left, is volcanic. So it is extrusive. It is aphanitic in texture. The diorite, the one on the right, is plutonic. Remember, volcanic means it's extrusive and plutonic means it's intrusive. Plutonic is inside the earth, magma related. Volcanic is extrusive, is lava related. And the diorite has much larger crystals. And if you zoom in on the, I know it looks like there's got big spots in here, but you actually zoom in on the rock itself, which is, my black bar keeps coming up. That's that bottom picture where it says close up, and it's a much finer grain. The grain itself, if you look at the grain itself, there's a very, very fine grain. With diorite, there's much larger sections that are the same. And like I said, they're basically cousins. We've got inside the earth over here, and we have outside the earth over here. Okay, basalt. Basalt is the most common extrusive, which outside of small, fine grain because it cools quickly. This is the most common extrusive igneous rock. This is what makes up your volcanic islands. Like I said, the black sands of Hawaii, don't go try to take it like I did. You get yelled at. You got poured all back. But that has to do with the basalt. Once again, volcanic, okay, extrusive, aphanitic, fine grain. You've got your deeper mantle rock of pyroxene. The only one that's really deeper than that is olivine. But pyroxene, and the deeper you are, the more calcium rich your feldspar would be. So basalt is the extrusive aphanitic. Its cousin is on the next slide, which is gabbro. It is the intrusive equivalent of basalt. So it's going to have the larger grain, a very, very fine grain on basaltic. All right, so now we've got mafic. Remember, this is magnesium and iron. Gabbro is the interior part, the cousin of basalt, which has larger grain. It is larger grain because it is magma related. It is a slower cooler, still has the same chemical composition. It just has to do with how quickly did it cool, because this took a long time to cool. It is pheneritic. It is larger, coarser grain. It is still mostly pyroxene and then the calcium-rich feldspar. This is what makes up the oceanic floor, your oceanic plate. So basalt is oceanic floor. Uh-oh, I lost my thingy. The granite is going to be your continental crust. All right, let's see. I'm getting there. Oh, yes, I'm sure I went so fast and you guys had to stop and go back, but I'm trying to get this done. I've got 7 minutes before my chemistry students go before the bell rings. Pyroclastic, we talked about these yesterday. These things are literally spit up out of the volcano, the ones that shoot through the air, big explosions, pyroclastic flows, and death and destruction, all that stuff you guys want me to talk about. But we have different types. And I mentioned this in some of the classes and not others, but tuff are the itty bitty, teeny tiny, razor sharp ash-sized particles, where if the people on Pompeii were alive, as the ash came down on them, it literally carved their lungs to ribbons as it was starting to turn into cement. Hopefully those people, not that it sounds horrible, hopefully those people had already died from the gases that were spit out by Vesuvius. And then their bodies were covered by the tuff, which then turned to rock on them and then preserved them. I mean, it was a rock mummy, but that's what happened to them. I'm not sure if I'm pronouncing this right, if it's Brescia or Brescia. I'm going to have to go back and like Google it and see if I'm pronouncing that right. But that's anything that's larger than ash. And it's going to have pieces of pumice and scoria, very small bits of it. But this is when you see a pyroclastic flow, which I hope you never do in your real life because you're going to die. Well, maybe not. But if you see them on movies and on documentaries, that pyroclastic flow, the particle that you're seeing, the smoke, that ash that you're seeing is a combination of these two. Oh, there's my reminder that I'm about to have to go and do, get ready for my class for chemistry. So I'm so sorry this went so fast. But like I said, you can go back and you can, oh, I so hope I haven't been muted this whole time. I don't think I was. No, I was not. Thank goodness. I was about to have a total proverbial cow there. But I'm gonna stop the presentation. If you need to, just go back, and I will be back tomorrow. Yes, tomorrow for me, meaning Wednesday.